Assalamu alaikum, it's me Wajiha Halil. Welcome back to my YouTube channel. So in this video we will learn what is quartile deviation. So the quartile, as you know, that is a measure of dispersion. As you know that you studied about the absolute dispersion and the relative dispersion. So the quartile deviation is one of the absolute dispersion. So first of all we will study about the interquartile range. Interquartile range is a term of quartile range, which is basically the difference between the upper quartile and the lower quartile. As you can see that the Q3 minus Q1 is called the upper and the lower quartile. So what is the quartile deviation? The quartile deviation is half of the difference between the lower and the upper quartile. Also, it is called the semi-interquartile range. It's up to you, whatever you want to call it. So this is called as quartile deviation and it is denoted by Q dot D. So the formula of quartile deviation is Q3 minus Q1, which is shown at here, and then we have the coefficient of quartile deviation formula, which is Q3 minus Q1 divided by Q3 plus Q1. So now we are moving toward what is how to solve the quartile division for the ungrouped data. So here I have an example of ungrouped data here. So as you know that in a median, in a quartiles, in deciles and percentiles, we need to arrange first of all. So after that we are continuing in finding whatever we want, either quartiles, deciles, percentiles and whatsoever. So here I am arranging the data. As you know that in our data we have 9 values, so that is why we are using the odd formula for the median, or you can say, or the quartiles or the deciles and the percentile. So because in our quartile division we have Q3 minus Q1 divided by 2, so for that reason I am finding here the Q1 and the Q3. So what is the lower quartile? Lower quartile is basically the first quartile of our quartiles. So because we have 9 values here which are in the form of odd values, so I'm using here n plus 1 divided by 4. 4 is just because of the quartiles divides the data into the 4 parts. That is why the 4 is in the denominator. So I'm here putting the value of n, which is 9. 9 plus 1 divided by 4, and solve it with the help of calculator, and the value returns is 2.5. The 2.5 value we did not identify from our data. We are identifying our data from this data. What is the second value? We are identify that what is the third value, but we can't identify what is the 2.5th value. Okay, so for that reason we are using here this formula, the second value plus 0.5 into third value minus second value. So now we know that what is the second value and what is the third value. So we identify from the our arranged data and then just put into this formula, and after that calculate it and finding out the first quartile. Same for the third quartile. So for the third quartile, we have the formula 3 into n plus 1 divided by fourth value, which is 7.5th value. Again, we are not able to identify what is the 7.5th value in our data set. So for that reason, we are using this formula where we use the 7th value plus 0.5 into 8th value minus 7th value. And with the help of calculator, we are finding our third. Once we are calculated our first quartile and the third quartile, we just put these two values into our quartile deviation formula, which is Q3 minus Q1 divided by 2. Again, with the help of calculator, you can find out what is the quartile deviation. Once we are calculated our quartile deviation, the next step is to find out the coefficient of quartile deviation. It is depends on the question, either it is required or not. So here Q3 minus Q1 divided by Q3 plus Q1. So again, we have the Q1 answer and we have the Q3 value. So we just put these two values into the formula and find out the coefficient of quartile deviation. So this is basically the example of the quartile deviation for the ungrouped data. So now we have the example of grouped data. So in the green color values, we have the actual data. These two columns are basically my own calculations. So again, as you know that in the median, quartiles, deciles and percentiles, we first have to identify either in our data set there is a class boundaries. If there is not, we need to calculate the class boundaries first. So I calculated the class boundaries first and then I calculated here the cumulative frequency column. Okay, and after that I just put here the formula of Q1. Whatever the formula is, we need to calculate first of all this term which is lie here, either that would be n by 4, 3n by 4 whatsoever. So n by 4, I put n by 4 here, and n is our the summation f, the sum of f. So I put here 120 divided by 4, which is 30. Now I need to identify where the 30 value is lies. So the 30 lie on this 51th value. So I just put the line in. So once you put the line by finding this value, so you have to identify what is L, which is a lower class boundary. From that line you identify the lower class boundary and then the interval and the frequency of that line, which is 28, the frequency that lie on this line, which is 28, and the C is basically one step back cumulative frequency. Once you find out all the values, you need to put all the values into the formula, and again with the help of calculator you find out your Q1 coefficient of quartile 1. And again the next step is to find out the third quartile. So we have in this third quartile we have this value here 3n by 4. So we need to identify the 3n by 4. Again 120 put here and we identify the 90. So this 90 value we need to identify where it is lie. So mistakenly I just put the line mistakenly. So we have to put this line below the 94 value because the 90 lies into the 94. So here one step after our line will be lie. So from this line, please ignore this yellow line and just see my highlighter where I point it out. So from this line we identify our L, which is the lower class boundary. So we have 159 and then we have class interval and then we have frequency of 18 and the cumulative frequency C is 76. Once you find out all the values, just put into the formula and find out the third quartile with the help of calculator. Again, you find out the first quartile and the third quartile, you need to put into the quartile deviation formula. So I just put here the both values of our quartile 1 and the quartile 3 and find out the quartile deviation. The next step is to find out again the coefficient of quartile deviation. Just write it down, the formula of coefficient of quartile deviation, and just put the values, and with the help of calculator you just find it out all the values of